In this lecture, we're going to explore try and catch blocks. And this is the foundation of how we work with exceptions in C++. We have mentioned that exceptions are a mechanism we have to say that something is wrong in our C++ program and provide a way to possibly recover from those problems. And the way you work with exceptions, you put potentially problematic code in a try and catch block. So you say try here, you put a pair of curly braces as we have here, and the code you think might cause problems is going to be living within the try block here. When you hit a point when you think that something might be wrong, you're going to throw an exception, and you throw an exception by using the throw keyword here. You can really throw a lot of things in C++. You can throw fundamental types, you can throw objects, and we're going to look at more details about how this works as we progress in the chapter. But for now, we are just getting the fundamentals right. Once you throw an exception like we are doing here, control is going to immediately leave the try block. So control is not going to go on and execute A++ or B++, for example. Code execution in this block is going to freeze at this line, and we are going to hit our catch block. We're going to hit the parameter here, and we're going to grab it in the body, and we can use it to do whatever we want. So once we throw an exception and we have a catch block, the catch block is going to catch the problem, and we're going to have a chance to fix the problem or do something about the problem in our catch block here. So within these two curly braces, we really have the freedom to do whatever we can to fix the problem that popped up in our try block here. This is the basic working mechanism of exceptions in C++. Okay, I just mentioned that you can really throw a lot of things in your try block. In this slide, I am going to bring your attention to a case where you throw a pointer to a local variable, and this is a recipe for a disaster. Here we have a piece of code we're going to be using to drive this home. We have our trusty try block, and we have a matching catch block here, which is going to be catching exceptions that we throw with an integer pointer type. And we are going to set up a pointer to a local variable here. So int ptr here is a pointer to this variable here, which is a local variable. But we go down here and throw an exception if c happens to be equal to 0. And you see, this is the value we have in here. So if c equals 0, we're going to throw this int pointer, and it is going to be caught by the catch block here. But the focus of this example is what happens if we throw this int pointer here. If we throw it, execution is going to freeze, and we are going to leave this try block. The moment we leave it, all the local variables are going to be destroyed, and hopefully you see the problem we're going to fall into here. We're going to catch a pointer which is pointing to something that has potentially already died. And this is a recipe for a disaster. If we try to use this pointer in our catch block, anything can really happen, because this memory may be already housing another piece of data which may be important to the operating system, and this may even crash. Sometimes we're going to get a valid value from here, sometimes we're going to get a crash. This is going to give us undefined behavior, and you should really be aware of this. So as a good practice, you should never throw pointers to local variables in your try block, and that's going to save you from possible headaches in the future. Another thing you should know is that if you allocate for dynamic memory in a try block and you throw an exception like we do here, if we leave the try block, this memory is going to be leaked, because we really have no way to release this memory by ourselves. If an exception is thrown, the C++ system is going to take things over, and it is going to move control to the catch block. So we have no way to really release this memory here, and it is going to be leaked. We have no way to release it. So as a good practice to try and avoid these problems, one should always avoid to use the new operator directly to allocate for dynamic memory in your try block. One might try to wrap this logic in an object and allocate the memory in a constructor, and when this object goes out of scope, the destructor is going to be called automatically, and this is going to release your memory. Another possible solution to this is to use smart pointers, and memory is going to be automatically released when we leave this try block as a result of this thrown exception here. So you should really be aware of this. Okay, one other thing you should know is that if you throw an exception and it is not handled anywhere in your program is going to crash because there is a serious problem that wasn't handled. This is the default behavior we have in C++. But it is relatively easy to avoid these kinds of crashes because we can catch the exception and handle it in whatever way makes sense for the program we are designing with C++. There is a simple requirement to exceptions that you can throw in your C++ program. If an exception happens to be a custom object, the custom object must be copyable. So it must have a copy constructor that is living in the public scope of your class. That's the requirement. If the copy constructor is either private, protected, or even deleted, you want to be able to throw exceptions because the exception mechanism really relies on copy constructors to do whatever it is we do here. So if we throw an exception, this exception is going to be copied, and what we have in our parameter here is going to be a copy, because if we don't use a copy, everything we had in this scope is going to die when this exception is thrown here. So the exception mechanism in C++ is going to make sure we have this copy. It is going to forward this to the catch block, and we will be able to use this thing in the body of our catch block to try and recover from this problem here. So again, the idea here is that any exception you throw in your C++ program must be of a type that is copyable, or a type that has a copy constructor that is callable from the outside. So a simple way to achieve this is to put this copy constructor in the public section of your exception class. And we're going to see ways we can achieve this as we progress in the chapter here. Now that we have a few basics about exceptions, it is time we headed over to Visual Studio Code and played with us a little more. Here we are in our working folder. The current project is try catch blocks. We're going to be playing with try catch blocks in our program. We're going to grab our template files pretty quick and we're going to put them in place. And we are going to open this little guy in Visual Studio Code by dragging and dropping here. One thing I want to bring to your attention is that I have updated my compilers. I have GCC 11, I think it was released a few days ago, and we also have access to Clang 12 now, so we can take advantage of these compilers. MSVC is also updated, so if we want, we can use this, and this is going to work just fine. So if you see different versions for these compilers, don't worry, it is just that I have upgraded to have the latest version to play with as I record this course here, but it's not going to change your experience with the course. Now, let's try and play with exceptions here. We have our main CPP file. We're going to clean up a little bit. The first thing I'm going to do is put in a simple class that we're going to be using to learn about exceptions here. It is nothing complicated. We have a simple constructor which says that the constructor was called. We also have a destructor here, and this is going to be our class here. I am going to head over in my main function here and put in the code to play with exceptions. We have two variables, A and B, and we're going to put in our try and catch block. The try block is going to be delimited by these curly braces we have on line 22 and 32 here. And the catch block is going to start at 32 and end at 34 here. Inside the try block, we're going to put code that we think might cause problems. And if we detect a condition for a problem, we're going to throw an exception here. Here we are creating a simple object, and this is going to call our constructor here. And the main reason I am using this object is to be able to see when an object is constructed and when an object dies. This is going to give us vital information to understand how exceptions work. So we are going to create this item object, and this is going to call the copy constructor. We're going to detect that B is 0, and we're going to throw this exception here. The moment we throw this exception, code execution is going to freeze at this line in our try block, and control is going to hop over in line 32 here, and we're going to hit our catch block. We're going to have our exception that we have thrown from our try block. So what we get in our parameter here is a copy of what we have thrown. So if we try to print out this exception here, we should get a 0 because we have thrown an integer of 0 in our try block. And the local variables we have are going to be destroyed the moment code execution leaves the try block here. I really want you to see this. So if we run this program, we are going to hop in the try block. We're going to throw our exception here, and control is going to hop over in the catch block, and we're going to print the message here saying that something is wrong. And if we print this exception parameter, we're going to see that it was a 0. Let's try and build and run this program to really show you this. So we expect to see the message from the constructor as a result of this object that we create here. When the exception is thrown, the local variables are going to die, and then we're going to leave the try block. We're going to hit the catch block, and we're going to print stdc out here and say the message. So let's pass this through GCC, our favorite compiler. The build is going to be good. We can clear and bring up a PowerShell window, and we're going to clear and run Rooster. Notice that this is exactly what we expect here. We are going to hit the try block, and we're going to create our object here. This is going to call our constructor. You see that here. When we throw our exception, control is going to freeze at this line in the try block, and any local variables we had in the try block are going to be destroyed. That's why we see the destructor for our item object called here. Then control is going to hop over in the catch block, and we will see the message in the catch block printed out here, and you see that the value we have thrown was a 0, and we can see that right here. This is how these things work. If we go in and, for example, throw in 110 and try to build again, we're going to build with GCC. The build is going to be good. We can clear and run Rooster. We should see 110 printed out because that's what we are throwing from our try block here, and we are catching the exception and handling it in our program here. And this is going to ensure that our program ends properly. Let's put in an stdc out statement saying done at the end. And I am going to show you that if you don't handle the exception, you're going to have problems and your program is going to crash. So we can simulate this behavior by commenting out the catch block. We can do something like this. This is going to be valid C++ code. And why do we have a squiggly line here? We have a try block. We can also try and remove the try block here. No problem. To really make this compile. Okay, I think this is going to give us what we want. And if we build, we're going to create our item object here. We're going to create the condition to throw this error, and that's that b is 0. So we're going to throw this exception here, but it's not going to be handled anywhere in our program, and our program is going to crash. We're not going to be able to hit the end of the program at line 38 here. So we want to see the done message. That's what I want you to see here. We're going to pass this through GCC again. The build should be good because this is valid C++ code. We're going to clear and run Rooster. And you're going to see that we're going to call the constructor. And our program is going to crash because this exception here wasn't handled. Let's try and run it again to really help you see this. We're going to run Rooster. If we run this, we're going to see that we're going to create our item object. Then we're going to throw the exception, and our program is basically going to crash. You see, terminate called after throwing an instance of int. So this is an unhandled exception, and the default behavior for the operating system is to terminate your program if you have any unhandled exception. And that's what we see here. If we view our terminal again, we're going to see that the terminate function was called to terminate our program. And this is basically going to make our program crash. We're not going to hit the end of our program. This is the point I am trying to make here. But if we handle this exception properly, let's do something like this and bring our code back to the original state. We're going to put in our try block, and we're going to catch the exception, and we're going to handle it. Now that we have handled this exception, the program is going to end properly because the operating system thinks that we have handled this problem, and it thinks there is no more problem, so our program is going to end properly. Let's build again, and we're going to see that we're going to hit the end and see the done message. We're going to clear and run Rooster, and we're going to hit the end of our program after we handle the exception here, this is what I want you to know. If we don't throw an exception, for example, if we change b to be something other than 0, our program is going to end properly. So this code that executes thing or fine is going to execute, and we're going to hit the end of the program here. Let's run the task to build with GCC again. We're going to see that the build is good. We can clear and run Rooster, and this is going to end the program. This is exactly what we expect here. Now, some people think that exceptions are a bad thing because they really make the flow of your program hard to follow. If things work properly, you're going to hit the try block, you're going to execute the code, and then you're going to hit the end. If things don't work, we're going to try and execute in the try block, and things are going to freeze at this line, and then the controller is going to hop over in the catch block, and then we're going to hit the end. Hopefully you can see that the flow is not that easy to follow anymore, because if you don't use exceptions, your program is just going to execute from top to the bottom, and there is no jumping around like we have with exceptions. But I am going to leave the choice to you to either use exceptions or not use them in your program. They are there. Some people like to use them, some people don't. You're going to have to make your choice on this here. My job is to make you aware of the possibilities. Okay, now that we have seen this, I think we can comment this out and show you that throwing pointers is a recipe for disaster. Let's comment this out, and we're going to go down and put in the code to play with us. Let's do this. We're going to create a C variable, and we're going to hit the try block. We're going to create a local variable here, and we're going to set up a pointer to that local variable. Then we're going to throw this pointer to our local variable, and the moment we do this, execution is going to leave the try block. You already know this. And we're going to hit the catch block. We're going to have our exception in the form of an int pointer, and we're going to say that something went wrong, and we're going to say that we have thrown an exception here, and we will try to dereference this pointer and see what it is pointing to. Hopefully you can see something that can go wrong if you set up things like this. Once we leave the scope of the try block, any local variable is going to be destroyed. So the pointer we have is not really pointing to something valid, but the time we hit the catch block, and we will try to dereference this invalid pointer, and this may give us undefined behavior in our C++ program. So be aware of this, and I strongly discourage you to not throw pointers to local variables, because this is a recipe for a disaster. Let's try and build and see what we get. We're going to pass this through GCC. The build is going to be good. We can clear and run Rooster. And you're going to see that this time things seem to work, but you won't get these results all the time. Let's try and build this with another compiler. For example, we can use the compiler from Microsoft. We're going to do that and pass this through MSVC and see what happens when we run our program. We can do this. We have all these compilers at our disposal, so we can play with them however we want. Okay, the build is good. We can clear. Let's clear properly and run our Rooster program. We're going to see our value here. So we have the same results we got from GCC, but this is a recipe for disaster. Hopefully you can see that we are dereferencing a pointer we shouldn't really be dereferencing, because it is pointing to something that has been already wiped out. So we have no business doing this. Some people must be asking, so if this memory has been wiped out, why do we get the 55 here, which we stored in there? Some people will think, this is working as we expect, so we have no problem here. But the memory location where this 55 lives no longer belongs to us, and the operating system is free to use it however it wants. So now you see that it is working and you get a 55, but we have no guarantee that if we run this program 10 minutes later or 20 minutes later, we're going to still find this 55 in here. So this is unreliable, because now you rely on what the operating system might do or not do with this memory location to make your program work. So don't do things like this, because they are going to make your program less reliable and less predictable. So let's comment this out, because we still have a few things we want to talk about. Another thing I should bring to your attention is that if you are doing dynamic memory allocation with the new operator in your try block and something goes wrong and you throw the exception, you want to have a chance to release that memory properly. Because as we have seen, the moment this exception here is thrown, Execution is going to leave the try block and we're going to hit the catch block. Any local variables are going to be destroyed, so this pointer variable itself is going to be wiped out and we will no longer have a way to release this memory. You should be aware of this. There are ways we can avoid these kinds of problems. For example, we can use smart pointers, and if you use smart pointers, the destructors are going to be called automatically when we leave the try block, so this is a way around this. But be aware of the problems that might pop up if you use the new operator directly to allocate for dynamic memory in your try block. You should really be careful about this. Okay, if we run the program, we're going to see that we create this object, but the destructor is never going to be called if we throw this exception here. Let's try to run the program to really show you this. We're going to pass this through our favorite compiler, GCC. The build is going to be good. We can clear and run Rooster. You see that we are going to call the constructor. Something is going to be wrong and we're going to hit the catch block. So we see the message here and our program is going to end. So we shouldn't really be doing something like this. But if you use smart pointers, you're going to see that the memory is going to be automatically released. We can actually try this out. We can hit the top of our file and include the memory header. And we're going to set up a smart pointer. We're going to comment this out and we're going to say std shared pointer to item. And we're going to call this item PTR, why not? And we're going to say std make shared, and we're not going to put in anything. We're going to call the default constructor here. This is the syntax we already know. Now, if we build the program, we're going to see that the constructor is going to be called once we do this. And if the exception is thrown, any local variables are going to be destroyed. So item PTR is a local variable, but because it leaves a smart pointer, it is going to automatically release our memory here, and we won't have memory leaks we would experience if we allocated for dynamic memory directly with the new operator here. Let's build this and we're going to see that this is going to work better. The build is going to be good. As you see down here, we're going to clear and run Rooster. Now everything is working as we expect and we are not leaking memory here. And this is really cool. Another thing I want to be super clear is that if you throw an exception and you don't catch it or handle it, your program is going to crash. We have seen an example about this, but I want this to be super clear. So we're going to set up an example like this, which is going to throw our exception here. And we're not going to do any kind of handling, and this is going to crash our program. Let's build and show you this. The build is going to be good as usual, but if we clear and run Rooster, we're going to see that our program is going to crash, and this is really bad. You should handle your exceptions. If you don't handle them in appropriate catch blocks, your program is going to crash. You should really know this. Okay, let's put a proper comment to make this super clear, and we are going to comment this out because we still have a few things I want you to see. And the next thing I want you to focus on is the copyable requirement for the types that you can throw as exception. And to learn about that, we're going to create a class and call it myException. It is going to have a default constructor here, but notice that we have a copy constructor in the private section of this class. What this means is that we can't really call this copy constructor directly. And this is going to violate the necessary requirement for this class to be used as an exception. So what we're going to do, we're going to set up a piece of code down below here. Let's put in the code that throws an object of myException as an exception. So we're going to hit the try block here, and we're going to create an object of myException here. And you see that if we throw this, this is going to give us a squiggly line, meaning that something is wrong. We can catch this and try to do something in our catch block, but notice that we have a problem here. So what is wrong here? We're going to try and build this with GCC and see the compiler error that is thrown. And we are going to see that myException const myException is private within this context. So what was happening, the exception mechanism in C++ was trying to copy this exception here and transfer it to the catch block. But this is not going to work because our copy constructor is private and it can't be called from the outside. So this is a problem here. If you want your object to work as exception, or if you want to throw your object, or if you want to throw objects of your class as exceptions, the copy constructor should be accessible from the outside. So we're going to face the same problem. For example, if the copy constructor is deleted, let's do that and really show you that. We're going to uncomment the line here that has the copy constructor deleted. If we do this, we are going to have the same problems. The copy constructor won't be usable in this try block here. So if we try to run the task to build with GCC, the build is going to fail because the copy constructor is deleted here. Okay, so this is something you should know. Another case where your object may not work as exceptions is if your copy constructor is protected. So we're going to go in here and mark this guy as protected. We can do this. And the class is going to be fine. But if we go down, we're going to see that it is not callable from the outside and our try block will not work here. You should be aware of this. But if the copy constructor is public, so let's go down here and make it public. We're going to put this in our public section. The class is going to work just fine. And if you go down, you're going to see that now our try block is going to work. Visual Studio Code hasn't realized that the problem is fixed now. But if we try to build the program, we're going to see that it is going to work. And we see that the build finished with errors. What is wrong here? Undefined reference to my exception. We have a copy constructor which is not defined. So we don't have a definition for this little guy here. But we can simply put a body in here and this is going to solve the problem here. This is going to be our definition. Sorry for this. We're going to build this again. We're going to pass this through GCC and the build is going to be good now because our copy constructor is accessible from the outside. So if you want to use objects of your own classes as exceptions, as we are doing here, the requirement is that they must be copyable. And what that means is that the copy constructor must be accessible from the outside. So the copy constructor can't be deleted in a private section or a protected section. It needs to be in a public section where it can be called from the outside. This is all I had to share in this lecture, giving you a simple introduction on how you work with exceptions. All your problematic code should live in a try block, and if you throw the exception, we are going to hit the catch block and we're going to handle the exception. And this is going to allow our program not to crash as a result of this thrown exception here. And this is something you can do to make your code much safer. We are going to stop here in this lecture. In the next one, we're going to explore why we would need exceptions in the first place. Go ahead and finish up here and meet me there.